What is the value of this expression? The numerator is first being multiplied, then it is being divided. So let's do the multiplication first, then the division. So I remember when I multiply, I need to do each piece separately. I'm going to do my factors first. 2.5 times 5. Well, that's going to give me 12.5. Just so you see, it's 5 times 5 gives me 25. And then 12. So I get 12.5 times 10. Sorry, let me do that in the red that I've been using earlier. Times 10. Well, 18 plus negative 10. 18 plus negative 10 from the two powers that I already have gives me 8. However, this is bad scientific notation, so I'm going to move that. So I really end up with, I move to the left, so I add 9. So I end up with 1.25 times 10 to the 9. All of that over 3 times 10 to the 4. Now, whenever you see things like this, you deal with each piece individually. 1.25 divided by 3. Well, 1.25 divided by 3. I'm going to say 3 can't go into 1. 3 can't go into 12 4 times. I get 12. And I get 0. And then I bring down the 5. 3 goes into 5 one time with finger of 1. And then I end up with 3. Let me bring up my decimal. 3 goes into 10 3 times. And then I get 9. And then I see this is going to be an endless loop. So I get 0.413. 0.413. And if you check a calculator, you'll get the same thing. I get 0.413 times 10 to the 9, and I'm dividing minus 4. 9 minus 4 is 5. So 0.413 times 10 to the 5. But I'm sure you've already noticed this is bad scientific notation, so I need to move this 1 to the right. To the right means subtract, minus 1. So I really am going to end up with, this is going to get a little weird, but I'm going to come up here, just so you can see this transition of here moving to here. 4.13 times 10 to the 4, because I subtracted here, because I moved to the right with this decimal. Great. Of the two quantities below, which one is larger? By how many times? Well, first thing I see, that's larger. Immediately, I see that immediately, because 8 is bigger than 5. Now, that's not the only question though. I make sure I just did a really bad job of showing this example. Which is larger? I first answer that question. I need to make sure I answer by how many times. So if I want to find out by how many times, I divide. And again, I'm going to divide each piece individually. Each piece individually. So let's start with the 10s because they're easy. That's 10 to the 8. I'm dividing, so I subtract. So 8 minus 5. 8 minus 5 gives me 3. Let's do the slightly tougher piece, which is 6.75 divided by 1.35. And in order to save time, I'm actually going to just simply come in and say, well, let's pull up the calculator. So I pull up, I make sure that it is in fact in scientific form. You can do that by clicking here. There's no reason to be using a standard calculator in 8th grade. And I say 6.75 divided by 1.35. And I get 5. So, thank you, calculator. I get 5. I check to see that this is in scientific notation. That number is, in fact, between 1 and 10. So, we're good. It is 5 times 10 to the 3 times, let me finish answering the question, times larger. So, in order to really get full points on this, I would need to actually write this. 6.75 times 10 to the 8 is 5 times 10 to the 3rd times larger than 1.35 times 10 to the 5th. Now, by putting that, this right here is a good answer. This is going to get me full credit on my summative and on the IAs and everything else. This is a clear answer. If I just put this part, I don't know which number is bigger. I don't know which number is smaller. That doesn't help. I need to know that this number is 5 times 10 to the 3 times larger than this number. Now that you've seen this one, please go down and do number 9. Pause the video now. Great, welcome back. I'm going to skip past these numbers because hopefully you remember you need to divide these. Then you need to divide these. Here, hopefully you remember that you need to multiply your magnitudes by each other. And you need to multiply your factors by each other. This, number 12, should be reasonably simple. Here, remember that you apply power of powers rule, and then you simply subtract your powers. The commutative property of multiplication, I'm going to actually have you Google the commutative property of multiplication and give this one a shot because it's actually rather interesting when you get to read it. So again, the best way to do that is to go to Google and Google commutative property. Thanks, guys. Commutative property. So moving things around, which states simply that A plus B is the same as B plus A. So go ahead and apply that same logic in this problem. Now, simplifying for number 15, because I think this is one that I've seen a lot of people make very silly mistakes on, so I want to address that. We need to check our bases. Here we have the 9s, we have the 2s. I'm not going to combine them. They're not like terms. So we'll go red for the 9s. 9 to the squared times 9 to the 4 is the same as 9 times 2 plus 4. That's going to give me 9 to the 6. Therefore, as hopefully you've already seen, that's going to then be times 2 to the 8, because 3 plus 5. Remember, multiplication of exponents, only multiplication of exponents gives you this. Now, one other thing that I want to address that is not on here that I've seen a bunch of people have asked me about. Mr., z to the 0 power is equal to 1, right? And I say yes, and then they say, okay, then z to the 0 power is equal to z to the first power. This is wrong. Here's why. Let's say Z were actually 1,000,000. 1,000,000 to the 0 power is equal to 1. 1,000,000 to the first power is equal to 1,000,000. These two things are not the same. So when you have something to the 0 power, the whole thing is equal to 1. This whole thing disappears and it equals 1. A number to the 0 power is equal to 1. It is not equal to that number to the first power. Hopefully this has been helpful. If you do have any questions, please feel free to raise your hand. The expectation is that you finish the remainder of this with the time remaining. You are working 100% silently, and you are raising your hand with any questions. Thank you all